Hey, what's up guys? Running a little bit late. I tried my best to get here on time, but a few minutes late, of course, so no big deal though. So no time limit on this one today. I basically we did like a couple of like lifestyle things before and last Saturday, and this week I want to cover something about nutrition, okay? So Raul, good to see you. Hope you're doing well, man. Let me know what's new in your corner. We'll be talking about nutrition today, but in particular, I'm going to kind of narrow in on the context. John, good to see you, man. Hope things are well. We're going to narrow in on the context, and that's in terms of how to source high quality fruits and vegetables, which seems like an easy topic on the surface. And Jenny, good to see you, which seems like an easy topic on the surface, but there's a lot that goes into it. And like in the past, maybe like 5 years ago, I thought, well, if I just ate like any fruits and vegetables, that's already like a huge step in the right direction. And that's right. I mean, of course, eating whole food, any type of whole food, even if it's like industrially raised, is far superior nutritionally versus eating cereal, for example. So there is that, but there's also like various levels of integrity when it comes to eating like different types of vegetables, or for example, like different types of farming systems that produce those vegetables. And it plays like actually like a huge difference in terms of the nutritional profile of the crops. So that's what we're going to cover here today. And I have some notes here because I always do these lives and then I end up like forgetting some things because I kind of just wing it off of the top of my head. Jason, good to see you. Ryan, good to see you. David, good to see you as well. And it's a lot of hearts. Thank you. Jason, good to see you as well. And then I always forget stuff. And then at the end of the video, I'm like, oh, you know, I wish I mentioned that. Yeah, no problem, Brendan. Thank you. Thank you for jumping in. And I'm like, oh, I wish I mentioned that, but I always miss it. So we're going to cover, once again, in short, we're covering how to select vegetables and fruit that have like a very high nutritional profile. So they have a lot of nutrition. So remember, I say this before, but it's a very important common theme. Basically put, you can't become healthy eating sick animals and plants, okay? So there's no way around it, and don't expect like to be buying, very cheap animal meat or very cheap, for example, vegetables, and then expect to optimize your health. Of course, it's once again better than eating cereal or very highly processed food for sure, but there's so much more that can be done in terms of sourcing high quality, for example, vegetables and fruits. So in the past, I thought, I could just buy anything and it's all great, but actually it turned out not to be the case. So let's start off with just like a little bit of cell biology. This part is for sure not that exciting. It's not that exciting, and I kind of hesitated about including it, but it's important because it kind of will help you appreciate the complexity of nature and the complexity of what has to happen for a plant, for example, to attain its nutrition, which you end up eating, and then that nutrition becomes obviously part of you, and that's how you stay healthy. And without kind of knowing this background stuff, you really kind of like don't appreciate it, and at least I don't appreciate it, and then kind of, for example, buy the cheap stuff, and then a lot of times you have lingering health issues and you think you're eating healthy, like I was, for example, and you wonder, why am I always feeling worn down, tired, etc., etc. So remember, in short, like a plant can't run after its food like an animal or like us. They don't have arms and legs. They have like a root system, and they rely on that root system to gather nutrition. And plants are basically omnivores. They eat like dead bugs. Also, they break down dead animals on the surface with bacteria and fungi that hovers around the rhizosphere of the plant root system. And they also mainly rely on a thing called photosynthesis, okay? And basically, in short, like what happens in photosynthesis is the plant is able to take water, air, and sun, and for the most part, convert that into ATP and glucose. The glucose is used to power various functions in the cells of the plant, but mainly also just distributed through the root system to feed a specific ratio of bacteria and fungi. And also to produce ATP. ATP is, in short, adenosine phosphate, or triphosphate rather, and it's basically used as energy in the plant, okay? So I have like some pictures here. I really need to figure out how to do a screen share on these Facebook Lives. I don't even know if that's possible. So in the meantime, I'm printing these out to make it a little bit more accessible. So yeah, in short, let's cover photosynthesis first, because that's kind of the base of how a plant attains its nutrition. So remember, it takes basically the sun, the air, and water, and it processes it through a system called photosynthesis. So remember, in any single plant, I'm going to kind of diverge here really quick. In any single kind of plant, you have like a bunch of cells, you know? And cells are the smallest living organism, and basically like a cell's function is really the same as yours. Sebastian, good to see you. Yep. Yeah, like a cell's function is really the same as yours. Their purpose is basically to gather resources. Jerry, good to see you. Hope you're doing well, man. To gather resources, to get rid of waste, and also to reproduce, okay? So each cell is basically trying to survive like you, and it does vary of the same things that you do. But within a cell, as you can see here by this picture, I'm going to try to kind of demo it this way. Yeah, this way it's a little bit easier. Boom. By this picture, you can see there's a lot going on in a cell, and we're not going to touch into the details of everything, but all of these little things are basically like things referred to as like organelles. And organelles are basically, for the most part, kind of like the same as like your organs or visceral tissue. And so remember, first, like the cell is a system of systems. So all of these things, just like all of your organs, rely on each other to do a specific job. So for example, you can't say, oh, my brain is more important than my kidneys, or my liver, for example, or my lungs. Like your brain can't function without your heart or your liver or your lungs. So you basically need everything working to be able to basically function and be healthy, okay? It's the same with a plant cell. And another way to look at it is, a way people can relate to is every company has like a myriad of departments, and all those departments need to work for the company to work. And if any one of those departments starts not working, George, good to see you. Alex, good to see you. If any of those departments start not working, then the company kind of crumbles and falls apart. It's the same exact thing with the plant cell, okay? So in the plant cell, you have like a couple things. You have the nucleus, the nucleolus, which is kind of like the command center, for example. You even have the mitochondria, which are these guys here, which basically produce energy or ATP for the cell to power its various functions. You have like the Golgi apparatus, you have the vacuole, which kind of gets rid of waste or stores waste as well, et cetera, et cetera. But the one we're going to be focusing on is basically the chloroplast, okay? And the chloroplast is these guys here, and they're basically responsible for the end product of converting, once again, the raw ingredients of sun, water, and air into, for the most part, glucose, okay, and ATP. So remember, ATP is produced by the mitochondria and the chloroplast, which both float around this thing called like the cytoplasm. It's kind of like a pool, like a swimming pool. So so let's kind of break that down. If we look closer to the chloroplast, I mean, we have a lot going on in there. So we're zooming in here. If we look closer to the chloroplast, so we kind of zoom in that guy, we have quite a bit going on. So we have like the outer membrane, we have the inner membrane, and we have like a bunch of these things, these pillars, these kind of skyscraper looking things called grana. And if you look closer at the grana and kind of break them apart, you have like various discs, as you can see here. And all these discs basically are called thylakoids. So if you kind of break them apart and look close to the thylakoids, we're going to go on to the next section here, which is basically a zoomed in version that I kind of drew based on the thylakoid. And this is kind of where the surface of the thylakoid is where photosynthesis takes place through basically a molecule on top of the thylakoid called chlorophyll. So basically what happens in the steps of photosynthesis, there are two different portions. So the first portion is light dependent. It requires the sun, for example, okay? Lokesh, good to see you. I hope my pronunciation is right. Let me know if that's correct. But basically it's light dependent, so it requires the sun, okay? And what happens is basically the sun strikes the surface of the thylakoid, which has the molecule chlorophyll, and it excites like a bunch of electrons in that chlorophyll, and those electrons then are pumped into the membrane of the thylakoid. And what happens, the membrane becomes negatively charged, and that negative charge then draws in a bunch of hydrogen into the body of the thylakoid. And as the hydrogen kind of builds up, once it reaches a certain thresholds, it begins to kind of dissipate or evaporate through this thing called ATP synthase, which creates ATP, which is an important step of the next process we're going to go over, which is the light-independent reaction of photosynthesis. Another thing that happens, that happens, which is very important for the light-independent portion, which is the second portion of photosynthesis, is the production of ATP. So basically, the negatively charged electrons. NADPH. So basically, the negatively charged electrons combine NADP with hydrogen to form NADPH, which is going to be an important part of breaking down carbon molecules in the light-independent reaction, which we're going to go to next. So let's break that down right here. So I'm just going to kind of go over this quick because, once again, I don't want to bore you guys. I love this stuff, but I totally understand it's not for everyone. I just feel it's important to really explain it because you appreciate, once again, the complexity of nature that had to take 4.5 billion years of evolution to create this, which forms the type of crops you see, and you'll understand why that's so important a little bit later in the conversation. So this is the light-independent reaction portion. I just drew it out because the stuff I found online was fairly incomprehensible, so I wanted to make it very simple. So here, once again, we have the disc of the thylakoid, and basically what happens here is in the stroma, which is basically the body of the chloroplast, so it's kind of similar to the cytoplasm of the plant cell. You have like a couple of free-floating carbon molecules. So for example, ribulose biphosphate, okay, which has like 5 carbon molecules. And what happens is it connects or joins with carbon dioxide to form a very short-lived 6-carbon chain molecule, okay? And what happens here is this is where NADPH and ATP come in, and why it's so important for them to be created in the light-dependent portion of photosynthesis. So they break apart this very temporary 6-chain carbon molecule into 2 different 3-chain carbon molecules that are then once again recombined to form glucose. So, and by the way, these 2 independent 3 carbon molecules are referred to as what is glyphosphorate? Yeah, phosphoglycerate. Okay, so we have phosphoglycerate here. Then both of them combine to form glucose. And glucose is basically where we go to the next section of this conversation, okay? Glucose is very important, and glucose is like a sugar, but it's very important for the plant's survival because it's basically how it attracts a specific ratio of bacteria to fungi, which set up the whole entire soil food web, which the plant is dependent on to stay alive and gather its nutrition. And remember, the more nutrition that's accessible to the plant and the more of it gets absorbed into the plant, that means the more nutrition you get. So this is where it's all interconnected, okay? And I have this picture here to kind of just have a quick view of what's going on under the soil, because a lot of times people look at the soil and they kind of, it really doesn't look like much. Omar, good to see you. It really doesn't look like much, but there's a tremendous amount of life going on in the soil that's very important for the health of the plant. And remember, the healthier the plant is, the healthier you are, because you can't become healthy eating sick and weak animals and plants. It's just common sense, okay? So basically, like I mentioned earlier in the conversation, plants can't run after their food, so they rely on their root system to gather those nutrients. But the root system isn't enough. The root system of the host plant isn't enough because it tends to be very bulky and it tends to be very dense, et cetera, and it can't quite access a lot of the nutrients, in particular phosphorus, which is very, very important. It's one of the 3 main macronutrients that a plant needs to thrive. So you got phosphorus, potassium, and nitrogen as well. So PKN, which is which are very common ingredients found in fertilizer, for example, and animal manure. So it can't gather those nutrients. And also the plant root system doesn't quite expand as far. So basically, once it kind of maxes out the nutrition available at the periphery or the kind of rhizosphere of the plant, for example, this is exciting stuff, George. Thank you, man. Rhizosphere, it kind of runs out of nutrition and it starts panicking, and basically, especially when it's low on phosphorus, which is extremely important for the plant's life. It sends out a hormone called stergalactin, and stergalactin kind of basically triggers fungal hyphae in the periphery of the plant to kind of awaken and start growing. And the fungal hyphae, or fungal spores, start releasing the fungal hyphae, which kind of interconnect with the plant. So now, in order for the plant to survive, it relies on bacteria, for example, and fungi. And every plant has like a specific ratio of bacteria to fungi that helps optimize the nutritional profile and health of that plant, okay? Every plant is different. And the type of fungi I'm referring to is arbuscular mycorrhizal fungi in particular, okay? Which basically is an endomycorrhizal fungi, which means it inserts itself into the cells, into these guys that we talked about earlier of the host plant. And they basically create like a symbiotic relationship with one another, where the fungi needs the host plant for its sugar, for its glucose that we mentioned before, because it makes glucose through photosynthesis, and the fungi can't survive without that. But the host plant needs the fungi as well, because it helps extend the root system up to like 10,000 to 100,000 times further than the host plant's root system on its own. So you can see how limited the plant is in terms of gathering nutrition if it doesn't have that accessibility to the fungi. And the bacteria is super important as well, because, for example, nitrogen is very important to the plant. And what the bacteria does is, for example, nitrogen cycling. So there's an abundance of nitrogen N2 in the atmosphere. About like 70 or 80% of the atmosphere is nitrogen. But the problem is a lot of organisms can't consume that form of nitrogen. For example, it's like being stuck in the ocean with an abundance of water, but you're dying of thirst because you obviously can't drink salt water. It's kind of the same problem. So the plant, throughout billions of years of evolution, once again has devised like a very elaborate system to be able to convert the non-bioavailable nitrogen, so N2, into a bioavailable form of nitrogen called NH2, which is called nitrate. And what happens is basically that bacteria, which mainly kind of hover around the rhizosphere of the plant's root system, in kind of soil aggregates plus around the tips of the plant, because the bacteria likes to kind of eat away at dying cell roots, basically takes the N2 out of the atmosphere, okay, and eats that for food. Now, and as a byproduct releases ammonium. So what happens is then protozoa, so here's where the soil food web gets its food, okay? So protozoa and nematodes, for example, eat that ammonium, and they release as a byproduct nitrites, so NH3. And then another set of bacteria eats those nitrites, and then as a byproduct releases nitrates, okay, so N2. And because the bacteria hovers around very, very close to the root system, in particular to the hyphae and the host plant's root system, as it releases nitrates, which are a bioavailable form for the plant then soaks up that nutrition into its nutritional profile, which then animals end up eating. And then if you eat those animals, you get that nutrition that has come from that plant as well. Or if you eat that plant, you get that nutrition as well. So this is like billions of years of evolution for this to actually work and happen, okay, guys? But these are like very important things. In particular, the ratio of fungi to bacteria near the plant is extremely important for the maximization of the plant's nutrition. And here's where the next topic comes in, and where a lot of people get confused. So a lot of times when you see a lot of commercials with big tractors and a lot of fancy technology and equipment of this sort, etc., it looks very fancy. It looks very well thought out. And you see these like acre and acre of the same crop, and they're harvesting all this food, and it looks super fancy. It looks like these guys know what they're doing, and it's great for the nutritional profile of the crop, but it's actually that industrial farming system which is destroying the nutritional profile of the crop. Because you see, first and foremost, like pretty much everything you see at the grocery store, even if it's USDA organic certified, comes from some kind of monocrop operation. There's no way they're growing it biodynamically and selling it at the grocery store level. So what happens is when you grow crops via monocrop, and for people that don't know what that is, it's basically when you have acre after acre after acre of the same exact crop, so like carrot after carrot after carrot after carrot for like millions of acres. And this doesn't seem harmful on the surface, but really monocropping is basically one of the biggest reasons for environmental destruction outside of car production and manufacturing in general, okay? Because for example, if you look at the earth and you kind of see it as an apple, and you shave off 70% of that apple, that's the ocean. And obviously you're not going to be farming there. But if you look at the remaining 30%, I mean, half of that is basically not farmable for one reason or another. And if you look at the remaining 15% or half of that is, you have large metropolitan areas which aren't farmed on for the most part, unless you have like a sprinkle of these urban farms, which I think is cool, but it's like a very small amount. And so you have basically like 5 to 8% of the world's surface that's able to be farmed for food. And monocropping is one of the most potent ways to destroy that soil. So which is the reason why we have soil degradation and a possible emergency situation in terms of food production in the near future. Okay, so first of all, it is harmful to the ground because it mainly disturbs that natural ratio of bacteria and fungi, which will thrive typically in a biodynamic or multi-species environment, which a lot of these operations are not. Okay, and what happens is when you start growing monocrops and you start destroying the soil health, remember the plant is only as strong as the nutrition it has available to it. And there's no nutrition where the soil food web is very poor and weak near the plant will be weak. And when the plant becomes weak, nature's way of getting rid of weak crops is through pests. It sends in pests to kill weak plants. And if you don't have weak plants, pests don't come around. Pests only come around when the plant is weak to get rid of it. It's kind of nature's way of getting rid of the weak and keeping those strong around. So if the farmer isn't willing to change their farming system, which they're not, especially in these huge industrial operations, what's the only thing that's going to keep them in business? A tremendous amount of use of pesticides, okay, and a lot of other synthetic biocides, such as synthetic fertilizers, pesticides, fungicides, rodenticides, et cetera, okay? The list is long. And what happens is when you use a lot of these chemicals, it destroys the fungi is very, very sensitive to this stuff. Especially the fungi is very sensitive to like huge machinery, which you see in a lot of these commercials and you think they're fancy, but it's actually that huge machinery that's destroying the the mycelium network, which the plants rely on for nutrition. And basically the ABS, so arborescular mycorrhizal fungi, which is we're talking about here, exists in basically the first like 4 to 10 inches of the soil. So when you have these huge tractors kind of stamping on there, digging up the soil, it's basically destroying this mycorrhizal fungi. And then remember, we mentioned if you just rely on the root of the plant, the fungi provides it 100,000 times more nutrition, okay? It's tremendous. So when you get rid of the fungi, it loses that huge advantage. So obviously, if the plant isn't getting that nutrition, you're not going to get that nutrition. Your body can't make nutrition out of nothing, okay? It needs it from outside sources, mainly plants, fish, animals, et cetera. So if you're not getting it from those sources, you're not going to be, if those sources aren't getting it, you're not going to be getting it from those sources, and thus you're not going to be healthy. It's very basic. So basically what happens is, so then the farmer has to dump a lot of these chemicals on there, which kills the soil food web even more, which makes the plant have less nutrition next season around, which makes it even sicker and weaker, which then results in having to use even more of those chemicals. So you can see kind of the cycle is not advantageous, and there's so many of those cycles that happen before the soil is completely destroyed and you can't farm anything on it. Remember, we mentioned there's only about 5 to 8% of the Earth's surface matter that's able to be farmed for food. So that kind of farming system is very troubling. And that's basically, for the most part, that's a lot of things that are sold at the grocery store from my observation. So there's also like a lot of misconception about, chemical use. A lot of people, they they tend to buy these chemicals because I just feel they haven't done the due diligence, the research necessary, and they kind of think it's okay because the government looks after their well-being. And the government is actually really good with keeping things away that kill you instantly, which is a great step in the right direction. It's better than not having anything, of course. But they're not too good about keeping things away that will kill you long term, okay? So for example, the average newborn born in America in a metropolitan area is born with trace amounts of 200 different industrial and agricultural chemicals in their bloodstream already, which is frightening, okay? And that explains, I mean, look, I always say this very often, but it's true, there's truth to it. And since we're on the weekend, simply go outside anywhere in America, and 9 out of 10 people you run into are full of obesity and disease, full of mental and physical pain. And so something's clearly not working, okay? So there's a lot of misconceptions about these chemicals. So first and foremost, you have to kind of, and it's all available, you guys, it's all available. You can go to the EPA website, you can go to the FDA website, you can go to pubmed.gov. The information is all there. It's definitely not being hidden from you. It just requires like a little bit of due diligence to go and do your own research on it and just see if you're okay with these practices. Because for example, a lot of people are shocked when I tell them, but complete formulations of pesticides are actually not tested for safety before they're approved for use on food that you end up eating, which is a shocker for everyone. They're like, well, what do you mean they're not tested? And that's exactly what I mean. Complete formulations, or the entire like actual end product that you, for example, buy at Home Depot to spray some weeds or something in your garden, is never tested for safety. Okay, so how the testing really works, and I'm pretty sure these procedures are going to change in 20 or 30 years because there's a lot of protest about it now and it's gaining a bit more momentum. But at the moment, how it works is basically in any chemical formulation, you have mainly 2 categories of ingredients. So one, you have like an active ingredient, which is like the main player. So let's use Roundup Ready as an example, since that's a very popular herbicide that's under a tremendous amount of lawsuits lately, although it's been scientifically proven to be completely safe, but it turned out not to be the case. So you have Roundup Ready, so you have the active ingredient referred to as glyphosate, okay? But with that active ingredient, you have a bunch of inert or inactive ingredients, and their job is to make that active ingredient persist in the environment longer or long enough to kill the specific pest or organism in question that's hurting the crop, and also to increase the potency of the active ingredient. So if you just test the inactive ingredient with the absence of the inactive ingredient, it's gonna be very, very weak, for example, and not do its job. But what's required for safety testing is, once again, you don't need to test the complete formulation of the product to get it approved by the EPA and then enforced by the FDA. You just need to test the active ingredient in isolation on its own, which is extremely troubling because, of course, it's going to be able to probably pass safety testing in that case. But if you tested the whole entire ingredient, which is actually how it's used in the field, the lethality of the product is going to be much higher. And you can check out Seralini Labs on pubmed.gov and find many, many studies. From my knowledge, he's one of the leading guys that tests the complete formulation and the longevity of that safety, et cetera, et cetera. And he most always shows that in the presence of those inert ingredients, the active ingredient is obviously stronger. This is common sense, guys, because that's the job of the inactive and inert ingredients, okay? To make the active ingredient stronger, more potent, and more deadly. And also just some other things to consider. I mean, look, there's a lot of industry influence with the government. It's not a surprise. These companies are trying to survive in a very competitive environment. And oftentimes it's easier for them just to get one of their executives in office to change the rules around a little bit, to basically, to allow that company to operate the way they want to operate and keep margins profitable, okay? They are under a lot of competition, a lot of international pressure, especially these days. So I understand, and it's up to you how you want to perceive this or approach this, but it's just important to understand that you have a lot of people in industry that are executives in the industry then go into like the FDA or EPA or USDA. And of course, there's going to be a lot of conflict of interest. I mean, just use common sense. I'm sure you've helped your friends get some jobs as well, okay? Although there are many other qualified people for that job. So on that, here's an example. So for example, here's Michael Taylor. So he's basically the executive of Monsanto. Obviously, Monsanto has like a very, very shady history. You can find this online very, very easily. One of their main products, Roundup Ready, which has glyphosate, although they mentioned it was never persistent, will never be persistent in the environment, is now found in most places in the US with 80% of the rainwater. Okay, and it's also going to be illegal very soon. I guarantee you in the next like 1 or 2 years, it'll probably be made illegal, just like DDT was, and a myriad of other chemicals that they've produced that they scientifically proven was safe because all the testing is done in-house by their scientists and not the FDA or EPA. And it turned out not to be the case, obviously, so it's silly. But basically here you have the executive of Monsanto, which poisons your food, as the saying goes here. I'm just reading off of that. And here you have the FDA food czar, the guy that's in charge of the FDA, same exact guy, okay? He's actually not currently the FDA director or the czar, for example, but he was for a very long time. And this happens throughout a myriad of different government departments. And you can see here his kind of career path, and I'm sure you could even find this on LinkedIn. So you can see he jumps around, you know, from Monsanto, executive of Monsanto, to the FDA, to the USDA, back to Monsanto, where typically their salaries go up about 1,500% as compared to government salaries. And then he's the food czar in 2010. So if you really don't believe that there's conflict of interest there, then okay, what do you want me to say? Okay, but that's something to consider, okay, to keep in your mind, all right? So let me just see here. I just want to make sure we got everything here. So chemicals, yep. Another thing that impacts the nutritional profile of the crop, and a lot of people don't know this, is a variety of basically genetic manipulation that has gone on through generations. So for example, farming kind of really took hold about 10,000 years ago when the Homo sapien has begun to domesticate crops and various livestock. But before then, you had a bunch of like Homo sapien, like hunter and gatherer, just relied on wild crops, mostly animals, wild animals and wild fish, because there's no pre-farming era, obviously. So, but when farming took hold, typically, obviously some of the farmers found some wild crops they could domesticate, which doesn't sound like too big of a deal. But the problem is when you domesticate crops, especially when you kind of genetically select for things, it typically degrades the nutritional profile of the crop. So for example, a lot of people don't know, but the carrot originated as like a white root in Afghanistan. This is like thousands and thousands and thousands of years ago. Over the generations, it's kind of made its way to India, where it became a purple carrot, okay? Then many, many generations later, it made its way to China, where it became a red carrot. Then many generations later, it made its way, I believe, to Turkey, where it became a white carrot. And then it kind of ended its pilgrimage in the Netherlands, where it became like an orange carrot. So a lot of people don't know, but naturally, the wild variation of carrots, they don't look orange. A lot of people presume carrots are orange. But for example, during this entire cycle of genetic manipulation, what happened is just the farming system destroyed all the anthocyanins in the carrot. So for example, a typical purple carrot, presuming it's grown in a biodynamic environment with a multi-species farming system, would have about like 900% more anthocyanins than an orange carrot, which basically almost has none. So anthocyanins are basically potent antioxidants, anti-cancer, etc., anti-inflammatory. They have like a lot of great biological actions in your body. So that's just one example, but this has happened basically throughout all of the crops that you typically see at the supermarket, okay? So you have to take into consideration, they're grown in a monocrop, which breaks down the nutritional profile, you know, it's not that great. They're grown with chemicals, which breaks down the nutritional profile even more by destroying the bacterial and the natural ratio of bacteria and fungi, which optimize that plant's nutrition. They're also that genetic manipulation factor that I mentioned. It's a far cry from its wild ancestors. So for example, spinach is touted as the superfood, but if you compare the nutritional profile of spinach to dandelion leaves, which you probably could find in your backyard, you'll see that dandelion leaves are nutritionally far superior, hundreds of percent more nutrition in a dandelion leaf than spinach, okay? And also the other problem with like supermarket goods is it tends to be like fairly old. So first, typically the crops are picked before they ripen. So that's a problem because the ripening process is what delivers the nutrition to the crop. And if you pick it before then, and they do that so it kind of looks fresh on the store shelf, which makes sense because you probably wouldn't buy it if it was kind of a little mushy, et cetera, et cetera. So I totally get it. But the end result is it's picked before it's ripened. The ripening process is what maximizes the nutritional profile of the plant. Then on top of that, there's a large transportation time, and then it sits on the supermarket shelf for who knows, like a week or two. Then you buy it, it sits in your fridge or counter for like a few days, then you eat it. So you can see, combining monocropping, which hurts the nutritional profile, genetic manipulation, which hurts the nutritional profile, chemical use, which hurts the nutritional profile, with that delay of time plus picking before it's ripened. You're pretty much getting water at the end of the day, and you're kind of buying these vegetables thinking they're actually health promoting. And once again, they're probably better than eating cereal for sure, but if you really want to optimize your health and nutrition, it's probably not going to help you do that. So another problem with supermarket stuff, especially in the US, maybe not the rest of the world, is that at least the last time I checked, the US is the only country that allows hydroponics to be sold. Omri, good to see you. Hydroponics to be sold as organic. Hydroponics is basically where it's kind of like a matrix looking operation where they don't even grow the crops in soil. So remember how we talked about all of this stuff and why I told you it was all important, the soil food web, et cetera, et cetera. Oops, it's upside down. Soil food web, the whole entire photosynthesis problem, importance, et cetera, et cetera. So hydroponics just bypasses all of this. So remember, the Earth has gone through 4.5 billion years of very complicated evolution and 5 mass extinctions where there's a tremendous amount of life on Earth and then all of a sudden it just vanished. That has happened 5 times already, and there's a presumed 6th mass extinction coming around the corner because of human activity, et cetera, et cetera. But also remember that the universe has been around 12 billion years to form the galaxy, to form the solar system, to form the sun, to form the life on the planet, to form the type of crops you see today, right now. And it's so complicated that even experts in the field are always constantly puzzled about the mystery of the universe. So the fact that hydroponics just gets rid of the soil is already, in my mind, kind of very, very, very questionable. So it's something for you to consider. And in fact, from my observation, like a lot of the tomatoes, blueberries, bell peppers that you would find at the supermarket are typically grown hydroponically, even if it's USDA organic certified, even if you're shopping at places like Whole Foods, for example. So, okay, let's see here what we got. Boom, boom, boom. Cool. One other thing I also forgot to mention, Brenard, give me one sec. So what is the best place to get our produce if we can't grow it? Yeah, I'll mention that at the very end. I'm getting to that. So I'm getting to the end right now, and I'll give you guys some resources. I'm not one to just keep complaining. I'm going to actually provide some very realistic resources to help you guys get from A to B quick. You don't have to grow it. Honestly, it's not for everyone. I have like some little teeny hobby garden going on, but it's not for everyone. And don't think like you just have to grow your own crops to be able to do it well. So, okay, let me see here. Boom, boom, boom. All right. Okay. Yeah, and just some kind of things about like some labels in the grocery store. So some typical ones to see are non-GMO. So remember, if you see non-GMO, that doesn't mean it's organic. That just means the seed itself is not genetically modified. Okay, which is great. You don't want to be eating seeds that are genetically modified through transgenesis in particular. So non-GMO will help protect you from that. If you want to stay extra safe, just stay away from all corn and soy products, and also cotton products as well. And then you'll be pretty much safe from GMO products. But remember, it doesn't mean it's organic. So I can have a non-genetically modified seed, but grow it with a lot of biocides, okay? Now, USDA organic also means non-GMO, but it also means those biocides aren't used, okay? And biocides are important because a lot of times people are like, well, I could always wash off the chemicals from my crops, and the important takeaway there is, first of all the chemicals are, all the pesticides in particular are systemic pesticides, so they're meant to be soaked up by the root system of the plant and actually become part of the nutritional profile of the crop, so there's no washing that off. Most of the surface level pesticides are just very minor. Most of it is in the actual flesh of the crop itself, so there's no washing that off, okay? But the good thing about the USDA, I do feel it's a really strong certification in terms of keeping those synthetic pesticides off of your food, but it doesn't mean it's nutritionally superior to conventionally grown food, because oftentimes a lot of the USDA organic certified produce in the supermarket is also grown via monocrop if it's in the supermarket. And monocropping is what determines, the lack of nutrition in the plant, because you get the most nutrition when it's a multi-species biodynamic farm, and it's very rare to find crops like that at the supermarket. So okay, so we covered quite a bit today. I think that's really good. Now, in terms of taking action, there are a few things you guys can do. So there's some books, okay? Boom, first one here, Deceit and Denial, great read, okay? There's also another book, it's actually like a whistleblower in Canada, but you get a lot of this happening in the FDA and USDA and EPA here as well. So this book here is great, so Corrupt to the Core. And then some actual books about plant nutrition, let's cover those. A great one, honestly, was just like very cool illustrations, is Teaming with Nutrition. So this one is awesome. I would recommend that for you guys. Let me see here, a few more books. Let's see. Tomato Land is really good. I have a few more books here for you guys. Tomato Land, if you want to educate yourself there. This book is kind of semi-related to farming, Sapiens. It really kind of goes over the principle that farming may have been the biggest curse that humanity has faced, because without the ability to domesticate crops and livestock, which basically farming is, you can't build armies, cities, dictators can't have powers. Humanity will be stuck in a hunter-gatherer kind of atmosphere, which is also limiting too, but you also have to take into consideration, that you don't have this overpopulation, dictators, egomaniac dictators that then enslave their own people. None of that is possible, because you don't need a military if you don't have crops. So if you have crops, you need a military to defend those crops, okay? And then you need a society to grow those crops. So you need a police department now, all right? And then you need a dictator or like a leader. And we know a lot of people that strive for higher levels of power probably do so with a little bit more incentive than just helping people, okay? Another great book, Chickenization. This one is great as well, Civilized to Death by Christopher Ryan. Seeds of Deception, Honest. Very good book, actually one of my favorites. This guy's really solid, did a lot of great work. This one is cool, Prison Chickens, Poisoned Eggs. You will, after reading this, you will definitely not purchase cage-free eggs anymore, or eggs with no label. I hope you don't, but you never know, man. Everyone's different. So, Pharmacology, written by a doctor, very good book, kind of a good entertaining read. And this is how you become healthy, guys. This is the pharmacy that you should be using. You notice the word farm in the beginning, okay? You're never going to become healthy just relying on pills and medicine. Everything has a place and time, of course, but if you think you're just going to, take a pill for something and then not get to the etiology of why that health problem exists, you're always going to remain sick, and all these big pharmacy companies and these doctors are just going to add you to their 401k plan. They're just going to add you to their BMW fund, and you're going to fund their lifestyle and remain sick. I've never seen people just take medicine. I personally never seen anyone just take medicine and not do a lot of lifestyle and nutrition changes, like a lot. And a lot of people need to do a lot, and just rely on medicine and pharmaceutical drugs and get better. They must always get worse, more and more sick and more obese over time. It's sad to see. And I hope one day, you see a lot of holistic coaching programs in hospitals, which you don't see, which is kind of sad, okay? Because if these people really wanted their customers to get better, they would have holistic coaching. Because remember, it's a belief system. I mean, short of a car accident, obviously, let's use some common sense, but it's a belief system that led a person to do behaviors that are self-abusive, that led to the obesity and disease to begin with. So without changing that belief system through good holistic coaching, which is basically what I do, no surprise the person is going to continue to be sick. Meat Racket, this book's super awesome. I had to read this one a couple of times. It basically reads like a thriller. Farming is just kind of like a background theme of it, but it basically goes over how factory farming was invented by two American business guys in the 1950s, and how they put the scheminess they went into to put a lot of the biodynamic farmers and small farmers out of business. Really shady business practices. Eating on the Wild Side by Joe Robinson, awesome book, okay? It talks about a lot of the shortcomings of supermarket produce. I got a decent amount of information from this book that we talked about in this video here. And so last but not least, my book, Anti-Factory Farm Shopping Guide. If you want all of those books condensed into like a very easy read with a lot of just quick pictures and quick videos, which you could get access to by just emailing me the receipt, you can support me and get that book as well. Totally up to you. I offer information like this and much more on various topics in the book and the videos. So hope you guys are going well. Really appreciate you guys showing up to these Facebook Lives. Even if my message gets through one person and causes them to shop better and not be deceived by a lot of greenwashing in the marketplace these days, that's already a victory for me, okay? Because that's huge. Because then that person is going to become healthy and motivate a few other people, which are also going to do the same things, etc., etc. And hopefully by the end of my lifetime, I see factory farms and industrial farming go out of business. And if those guys go out of business, fast food will go out of business, because fast food relies on, and processed food rely on, those industrial operations. And once those guys go out of business, like, America will start heading back into a direction that's more healthy and health conscious, and not relying on these pharmaceutical crooks, which do have a place in time. I'm not saying medicine doesn't have a place in time, but the way it's used these days as like a first course of action without even attending to the belief system or the behavior patterns that led to the person's problems is fairly criminal, in my opinion, and not right for the customer. So I hope a lot of medical doctors change their ways, and I hope a lot of pharmaceutical companies become more patient-driven and really want to see their patients get better, instead of making dependent clients out of them and selling them drugs that, at the end of the day, without doing the holistic changes, without doing the lifestyle changes, literally don't do anything except make situations worse. Because it's the equivalent of, you have a rock inside your shoe, and instead of taking the rock out, which a 5-year-old child would understand to do, you just take painkillers and continue to walk with that rock inside your shoe, which is crazy to me. And people do this all the time. And that's why 9 out of 10 Americans you run into today are full of obesity and disease, full of mental and physical pain, because they're looking for these quick fixes. And there are, unfortunately, no quick fixes, guys. You have to make the change deep down inside, okay? Or you're going to be just a product of the medical system, which is going to milk you for all the money you have. And you're going to be just on the 401k plan of a lot of these doctors and pharmaceutical companies, and they're going to be living a great life with all the money they're making off of you while you're getting sicker and sicker and sicker. So take care of yourself, put your health first, okay guys, and I care about you, and have a good weekend, okay?